So, you want to run production on your CNC router. Making 50, 100, 500 of something means you need to prep your machine, tools, materials, files, and your workflow. This video contains all the information and steps you'll need to find success. This summer, we will be at AWFS. That's the Association of Woodworking and Furnishing Suppliers show, July 22nd to the 25th in Las Vegas. Come by and see us as well as this production run output. These Carbide 3D bottle openers will be there. If you regularly watch this channel, you know I like items with utility. These certainly have that. Made on our Shapeoko 5 Pro 4x4, initially in rounds of 106. And that would be some foreshadowing right there. These are just the type of tchotchkes you may find a client asking for. The preparation for such a production run begins with your machine. No matter the CNC router you are running, no matter the type of project you are making, a flattened work surface is critical to your success. Because this project involves large sheet goods and fine details, this first step is the most essential. If you're a Shapeoko owner, we have a variety of flattening files on CutRocket. If you haven't recently run a pass, do it fresh. Moisture and temperature changes in your shop, vibration over the course of projects, and other external factors can greatly affect the characteristics of any hybrid CNC router bed. Surfacing is a step you need to take before taking on a large project. Here's where a consistent theme appears once again. Quality materials matter. I'm using Baltic birch plywood. This type of plywood not only looks better, it is also far more consistent in Z-dimensioning. That flatness is critical. Now, I'm still going to exceed the tolerance of that, but that's yet to come. Whether you're making large objects with fine details or many small objects with fine details, the stock preparation has a massive effect on your success or failure. Buying those better materials certainly helps, but as you'll see, it's no guarantee. Now, there is another critical stock-related factor you must account for. This is a 48 by 48 sheet. Holding the edges is not enough. Mid-sheet control is required to ensure accurate cutting. This applies to details as well as contour cutouts with tabs. If the Z relationship isn't consistent across the 48 inches in each direction, all kinds of bad things can happen, and they will. Here again is where we have an asset on CutRocket designed to help. This file outlines the slats and T-tracks for the 4x4 Shapeoko hybrid bed. When put on a separate layer, it functions as a guide. I'm using it here to ensure the work holding screws meet MDF slats, avoid my parts, and remain outside of my tool paths. Milling screws? Bad. Ask me how I know. When I run the first part of the program, you'll see just how much the center of the sheet is distorted. It's enough to ensure the failure of the majority of the parts. The link to download the hybrid bed guide is in the description. Two factors in this section. Factor number one, the feed speeds and depth of cut. As you run more and more of a single material, you'll dial up and dial in those settings. Particularly when it comes to refining your depth of cut. If you can avoid an extra pass on any given tool path, thereby saving 106 passes of, say, a pocketing operation, your time savings will be substantial. The only way to refine these aspects of your file is to run the project. The principle of 3 applies here. By the third run, your program will be on point. Factor number 2, the order. And this is something you can work on before putting an end mill to wood. As much as possible, like end mill operations should be grouped. Fewer tool changes means faster production times. Also, utilize groups to simplify enabling or disabling one portion of a program. For instance, I want to run just the work holding locations operation, then stop down and screw the sheet to the machine before I make the production run. Carbide Create makes this super simple. Toolpath groups are the key. I have one group for work holding and 2 more for details and contour cutouts. A little strategy secret here, I'm running a 1/8 inch end mill around my profile cut to ensure these lower cutting forces keep chip out from occurring around the bottom of my design. This bit of knowledge comes from the prototyping stage. Normally, I chamfer everything, but on this project, hand routering both sides of the openers was the best plan. However, I did later add in a pass on the inside rim of the opener section to eliminate some of the fuzzies that were there because of the upcut end mill. This was a later optimization of my program that allowed me to stop having to file every single unit, saving time and therefore money. One last note before we run this thing. Going to the very edges of your stock or your machine bounds to save $4 in material, thereby risking the entire production run on the sheet, is not a risk I want to take. This has me leaving plenty of space around the edges. Now, mind you, I did run into one problem. I left one in the lower right corner, which had Sweepy contacting the bit setter on the first round, and that cost me 6 parts. Mistakes are unavoidable. It's just part of the learning process. The only way to figure these things out is to run it. One last thing in this segment, if you find yourself in a situation where you have to go to the edge of your stock in order to make the project worth doing, you have a problem with your pricing. Fix that. Layout set, 4 foot by 4 foot sheet cut, loaded into the Shapeoko, edge work holding applied, and work holding tool pathing enabled. Here is where that need for center work holding becomes obvious. My work holding tool paths are deliberately shallow to allow for the variation in Z depth. These numbers aren't horrendous considering the size of the sheet, but the details are designed to be cut 0.5 millimeters into the handles of these bottle openers. Without center work holding, most of this production run would be unsuccessful. As it is, the margins are going to be challenging, but I don't know exactly how challenging just yet. Now, pushing the machine to cut this large of an area with this level of detail creates some practical issues. The first is time. This is a multiple hour cut. No one wants to babysit the machine for 10 to 12 hours. This is reason enough to cut down the size of the sheet. For me, 6 hours is a plenty long cut. By cutting my sheet in half, 48 by 24, I gain some other things. Work holding is radically simplified. Something 24 inches wide is super easy to work hold and ensure consistency across. All of this edge holding is super simple. Fewer screws in the center means less time spent with that process. Less space across the bed reduces the Z variation if you refuse to listen to the above advice regarding flattening the bed. I could reduce the amount of details to reduce the machine time, but yeah, I'm gonna have to do that. My 48 by 24 sheet turned out really nice. This makes the case that a 4x2 Shapeoko 5 Pro is a wonderfully capable machine for those of you with less space in your shop. Limited space doesn't mean limited capability. Your design may need to change in order to meet the demands of mass production. I went through this process. Making over 100 of something at once is different than making one of something at once. This is why every car looks like a Corolla, except this one. Now, to increase my yield across a sheet of 106, I would improve my work holding, particularly along the front and back edges. This might require some printed clamps. Otherwise, I just go smaller. I actually like the 24 by 48 sheet a little bit more. I like the timing of it more. I like the control of that amount of pieces. I can make those pieces while I'm finishing off some other ones. I think it's a better flow for the overall project. This also means that if catastrophic failure occurs, 51 parts are lost rather than over 100. Here, I let it roll so you can see the results of even slight variations on this particular design. If I were making this as a product for a client, I'd probably use a laser for the lines. Clean and fast, lasers are good at shallow patterning. What I did was alter the design to reduce machine time and increase the margin for error. The more flexible and creative you can be while adapting your design to the needs of mass manufacturing, the more success you're going to find. Now, another quick tip here, tighten Sweepy with an Allen key. Be sure the latch is secure in order to withstand 2 to 3 hours of vibration during a single tool path. This is another adjustment to workflow designed to meet the demands of production. Okay, here's the deal with plywood. If you buy good plywood, you can utilize the layers of it to create contrast. I nailed it here on sheet number 3. A 1.8 millimeter cut down yields me beautiful contrast in that layer of the plywood. And this is where having quality materials matter because there are no voids. I only encountered one little section where I had to trim it up a little bit. Otherwise, it's super consistent. With cheaper plywoods, you're gonna have veneer that you don't like. It's gonna be spongy and garbage, and you're gonna have voids, and you're gonna lose parts. Here, my yield in sheet number 2 was 51 out of 51. I didn't lose a single part. That said, my design still exceeded the Z variation across the sheet. I found it to be 0.5 to 0.75 thicker or thinner across that 48 by 48. So trying to carve 0.5 millimeters into it with a grid, not going to work when that can be double or more the depth specified. The other limitation with plywood is you cannot surface it. With hardwood, I could go ahead and surface it and then add all those details, but the amount of extra cost is going to kill this particular tchotchke project. So quality plywood was the solution, and by the third run, these are looking really good. Quality materials matter. Full stop. The good fun is seeing so many parts made to perfection on your machine. As the process gets dialed and the parts get super clean and refined, you'll feel that pride of having created that program which just bangs out parts consistently. The bad is the amount of risk along the way. Every operation brings the possibility of ruining a part and therefore money. Each handling, transport, sanding, cutting, lasering, all of it creates opportunity for failure. Sometimes failure of many parts at once. But I've said before, there are no failures, there are only successes and learning. I did do some learning on this project. The ugly, manufacturing is boring and tedious. So many reps of the same thing over and over. It makes you appreciate the work done by our guys here in the shop or in your local factories. To all the people repping it out to make things in America and across the world, I salute you. Buy new tools for a production run. Charge the customer for the tools required. Build it into the bid. You're running 50, 100, 500 of something. That's real wear and tear on any end mill. Personally, I do not want an end mill going south on piece number 32, which I had in this particular build here, thereby ruining or severely altering my next 58 parts. Sanding, routing, or otherwise wasting time and money trying to salvage those other pieces is costing you money. Using a dull downcut end mill during that first sheet cost me a ton of extra work. Contrast that with my second sheet and you can clearly see how much cleaner the cuts are. Same model end mill, much different results. Buy new end mills for client work, especially for high volume runs. You've been warned. So what did I learn? That I hate production, at least as an everyday pursuit. I do take pride in a sheet of perfectly cut parts and a refined program I've tweaked until it's ideal. But routing, sanding, and screwing 300 of something, it's not what I want for my daily. Now, designing those parts and creating the systems to quickly and efficiently produce them? Yes, please. Speaking of efficiency, it matters. I've said saving 25 seconds is meaningless, and it is when you're making 5 to 10 of something. The moment you're making over 100, now you're saving something. But the CNC side of things is minor compared to the finishing processes. Every time a part is touched, sanded, stacked, boxed, transported, or assembled, time and money are being eaten. The quicker those processes can be refined or reduced, the more profit there is in the parts. Even over just this run of 300, I was steadily refining what I was doing, the tools I was using. I went from hand sanding to utilizing the orbital sander. I think if I had a belt sander at the handy, I would go with maybe a 320 belt on that, so it was nice and fine and I could just touch the bottle openers to it to get that laser gunk off. And this again is where quality materials matter, because that top veneer will be thick enough that you can sand it a little bit without going through it. I'd also, for putting screws in, I would make little pockets so that as I put the screw in, it could twist the bottle opener a little bit without knocking all of the rest of them off of my work surface, and I could be reaching for another screw. Every second I save doing that, being a little more efficient, gives me time to do something else. Little jigs, special setups, and things you know that you're going to do for any step of the process, yeah, all that becomes critical. And here's another boss move. You can use the CNC to align your parts by creating the start for them. Here, I'm going ahead and cutting just a tiny little hole to align the screws for each metal insert. This worked out fantastic. It not only holds the front of the screw when I go to put it in, but it also allows me to be able to put in the inserts exactly straight each time. So once you have it set up, once you have a couple little jigs, you could always store those. And if I spent the time to develop bottle openers for one client, you better believe I would want all that time spent on the systems, the ideas, the design, the refinement, knowing what parts to order from Amazon, and all the other things to pay off again. So I'd be pitching those suckers to another company, especially if the people were super happy with them. You got to follow the marketplace a little bit and increase your own efficiencies on your side. You'll make more money, which might make you happier. Actually, being more efficient would make me happier first. Making more money would be another factor in that. I like both of those things. Do you feel the same? Let me know in the comments below. Future Kevin jumping in here right at the end of the project as I'm finishing everything up, and I want to come back to that quality materials theme because I just mentioned the idea of screwing things into the front and also what you would have to do with the back in terms of sanding. I absolutely experienced this. So this is higher quality plywood. This right here is Baltic birch. Best you can do. Yes, I know it's Russian, but this is the best stuff. Has a lot of nice layers. I got that good contrast on most of my parts. It's been holding screws really well. You can set the clutch on your drill. Works perfectly. This stuff is called something else. This is Dragonply, My Ply. I don't know what the heck this was. Bought when Baltic birch went through the ceiling. This stuff is good, but not great. So when you compare it directly to Baltic birch, I'm getting screws that strip out more often. Definitely don't want that. And also, when I'm sanding on the back, yeah, the veneer goes right through because that layer is so thin. Quality materials, yeah, I said earlier, they matter. This is just reiterating it. Spend the money, charge your client, produce something that's a little bit better. And you know what? The other thing you can do is it'll lessen your frustration as you go through your project. Fewer failed parts equals more profit for you, despite the fact that the upfront cost of the material is a little bit higher. Back to it. It's also worth noting that you will notice more imperfections than your clients ever will. So give yourself a little bit of grace when you're making these things. I know you're constantly refining and making the process better. We've touched on some of that, but definitely there are saleable items that do not meet your quality standards right away. You'll have to find that line. Depends on the client, depends on the item. Depends on the material you're using and how obvious the mistake is. But cut yourself a little bit of grace. I know how you are out there, woodworkers. I know. I'm the same. Okay, here's a list of the things you'll need to find success with production. 1. A well-maintained and prepped CNC machine. 2. Quality stock. 3. A refined design. That's your CAD file. 4. A repeatable and reliable CAM execution. 5. An efficient post-processing plan. And of course, you're going to need some clients who love your product. Now go forth, give production a run, and we'll be back here in the studio with more information, ideas, and inspiration.